Good day everyone, this is Teacher Rovi and today we're going to discuss about naming ions. But first, let us define what is an ion. An ion is an atom or group of atoms that has a net positive or net negative charge. Alright, so an ion actually can be a cation or an anion. Alright? When the ion has a net positive charge, it is called a cation. When an ion has a net negative charge, it is called an anion. Alright? There you go. Also, ions could be monoatomic or polyatomic. Let me just erase this one. Okay. When an ion is monoatomic, it is composed only of one atom. While if it is polyatomic, that means that ion is composed of more than one atom. Alright? So that's it. Now, let us proceed with the nomenclature of ions. Alright, so first, let's start with the basic ones, which is the nomenclature of monoatomic ions. Alright, so let's start with the monoatomic. Okay. Now, how do we name monoatomic ions? Alright, if you're gonna name a cation, alright, let's have some examples. If you're gonna name a cation, let's say this one. Let's have lithium positive. How are you gonna name this cation? So first, you just have to name the metal, which is lithium, and add the word ion. Alright, so that is lithium ion. Now, how about another example? Let's have Ca2 positive. Ca2 positive. How do we name this? Let's name this ion. First, name the metal, which is calcium, and then add the word ion. As simple as that. Let's have another example. How about Al3 positive? Okay, Al3 positive is actually aluminum. Again, name the metal first and add the word ion. Aluminum ion. There you go. Okay, but that is only applicable for those metals who has one possible charge. What if the metal has two or more possible charges? Let's have some examples. Let's say chromium or Cr2 positive and Cr3 positive. How are you gonna name this? Just name the metal first, which is chromium. Then, enclosed in a parenthesis is the Roman numeral representing the charge, which is 2. Chromium 2 ion. There you go. How about this one? Cr3 positive. So this is chromium 3 ion. There you go. Alright, let me just adjust the frame. There you go. Okay, so let's have other examples. Okay, how about this one? Sn2 positive, Sn2 positive, and Sn4 positive. So the name for the metal Sn is tin. So tin 2 ion, and then we have tin 4 ion. There you go. Alright. How about this one? Alright, this one, Hg2 positive and Hg22 positive. Alright, we have Hg2 2 positive and we have Hg2 positive. Okay, this one is actually mercury. So this is mercury 1 ion, and this one Hg2 positive is mercury 2 ion. Please take note of this, that mercury 1 ion is actually Hg2 2 positive and mercury 2 ion is Hg2 positive. Alright, there you go. Now, that is how you name monoatomic cations. How about the monoatomic anions? Let me just erase some of the things that I have written. Okay. I hope that you understand the first part of this discussion. Now let's proceed with naming monoatomic, still monoatomic, but this time let's have an ion. Alright, so let's have some examples. Okay, so for example, we have F negative. How do you name F negative? Right? So you take the root term for the element and add the suffix "ide." Alright? So let's take the root term for fluorine and let's add IDE, and that will be the name for this ion. So this one is actually called fluoride. Fluoride ion. Alright? Let's have another example. Let's have Cl negative. Cl negative, let's take the root term for chlorine atom and add IDE suffix. So this one is actually chloride ion. Alright. Let's have another example. Let's say O2 negative. Alright. Let's take the root term for oxygen and add the suffix IDE. So this one is actually oxide ion, O2 negative. Alright, let's have Se2 negative. So let's take the root term for selenium ion and add IDE. So this is selenide ion. Alright. How about this one? Te2 negative. So let's take the root term and then add IDE. So this is telluride ion. There you go. How about this one? C4 negative. So let's take the root term for carbon and add IDE. So this one is actually carbide ion. Take note. Another form for carbide ion is C2 negative. Alright. Okay. So that's it. That's how you name monoatomic cations and monoatomic anions. Now, how do they form? How do atoms form their ions? So an easy way for you to remember is for group 1A, all of the atoms here form a cation with one positive charge. For group 2A, the atoms form their cation with a 2 positive charge. For 3A, 3 positive. For 4A, 4 positive and negative. For 5A, 3 negative. For 6A, 2 negative. For 7A, 1 negative. And for 8A, 0. Alright, so that's it. Now, let us proceed with the naming of polyatomic ions. Alright, so again, we will use this diagram for us to derive some of the common polyatomic ions. Okay, let me just adjust. Okay, so let us derive one by one the polyatomic ions from the reference ic acid. So let's do this one by one. Okay, let me just erase. Okay, so let's take HClO3, which is the chloric acid. Chloric acid. Alright, now if we remove the hydrogen atom from the formula, it will become ClO3. And the charge, since this is an ion, is 1 negative. Again, for some reason, the number of hydrogen atom that we remove is also the same with the numerical value in the charge. So this is 1 negative. And this is named as chlorate. Okay. If we add one oxygen atom to ClO3 negative, it will become ClO4 negative, and this is perchlorate. If we remove one oxygen atom, it will become ClO2 negative, and this is chloride. And if we remove again one oxygen atom, that will become ClO negative, and this is hypochlorite. Okay, let me just adjust the frame. There you go. Alright, so let me erase first what I have written, and let's do the derivation to other ic acids. Okay, let me erase. Okay, that's it. Now, let's try iodic acid. We have HiO3. If we form the 8th ion, that will become IO3 negative. Alright, so this is called iodate. Alright, now if we add one oxygen atom to the formula, that will become IO4 negative, and this is called periodate. If we remove one oxygen atom from the formula, that will become IO2 negative, and this is called iodide. And if we remove again one oxygen atom from the formula, that will become IO negative, and this is called hypoiodide. There you go. Alright, let's have another example. So I hope you are getting this, because we're actually deriving most of the common ions, or most of the common polyatomic anions. Alright, let's take nitric acid. So the formula for nitric acid is HNO3. If we remove the hydrogen atom from the formula, that will become NO3. since this is an ion, the net charge is negative. And the numerical value for that is 1 because there is only one hydrogen atom that was removed. Okay, so if we're going to add one oxygen atom from the formula, it will become NO4 negative. And this is called, alright, let me just go back here. So from nitric acid, it will become nitrate if we remove the hydrogen atom. Right? And from nitrate, if we add one oxygen atom, this will become a pernitrate. Right? And then if we remove one oxygen atom, that will become NO2 negative. This is called nitrite. And that's it. Now let's have another example. Let me just erase. So the more examples that we can discuss, the better. So you can actually understand the lesson. Let's have bromic acid. Alright. So for bromic acid, we have HBrO3. If we remove the hydrogen atom, it will become a bromate ion, BrO3 negative. So this is called bromate. Okay. If we add one oxygen atom from bromate ion, it will become BrO4 negative. So this is perbromate. Okay, if we remove one oxygen atom from the bromate ion, it will become BrO2 negative. So this is bromide. Sorry for my penmanship because I only have a very little space in my drawing pad. Alright, so if we remove one oxygen atom again from the bromide ion, the formula will become BrO negative. And this is what we call hypobromite. Okay, there you go. Alright, so let me erase this again. Okay, so I hope you're taking notes for the polyatomic ions that we're deriving. Alright, there you go. Now, let's have another example. Now this time, let's use H2CO3 or carbonic acid. H2CO3 is carbonic acid. So if we remove the hydrogen atoms, it will become CO3. Now, since this is an ion, the CO3 must have a negative charge or negative net charge. But what will be the numerical value for that negative charge? So remember, we remove hydrogen atoms. So the number of hydrogen atoms that we remove also represents the net charge. So this will become 2 negative. So this is called carbonate. There you go. Alright. Now, if we remove one oxygen atom from carbonate, the formula will become CO2 negative. And this is called carbonite. There you go. Alright. Now, let's proceed with another example. Let me just erase this one. Okay. So let's proceed with sulfuric acid. So H2SO4. So from sulfuric acid, if we remove the hydrogen atoms, it will become SO4 2 negative. Again, why 2? Why is the numerical value 2? Because there are 2 hydrogen atoms that was removed in the formula. So this is sulfate. Alright. And if we actually add 1 oxygen atom in the formula, it will become SO5 2 negative. And this is called persulfate. And if we remove 1 oxygen atom from this formula, it will become SO3 2 negative, and this is called sulfite. And if we remove again 1 oxygen from the sulfite ion, it will become SO2 2 negative, and this is called hyposulfite. There you go. Alright, now let's proceed with another one. Let me just erase this. Alright, there you go. So what we are actually doing, we're deriving the polyatomic anions from the reference ic acid. So let's have boric acid, because these are the most common polyatomic anions. So we have H3BO3. So if we remove the hydrogen atoms from the formula, it will become BO3 3 negative. And this is what we call borate ion. Alright? And that's it. Now let's derive the polyatomic ions from phosphoric acid. Okay. So for phosphoric acid, the formula is H3PO4. So if we remove the hydrogen atoms, it will become PO4 3 negative. Alright, and this is called phosphate. Alright, so if we actually remove 1 oxygen atom from this formula, it will become PO3 3 negative, and this is called phosphite. And from phosphite, if we remove again 1 oxygen atom from the formula, it will become PO2 3 negative, and this is called hypophosphite. There you go. So what we did, we derived the most common polyatomic ions from the ic acid. So what is important here is that you know how to navigate this diagram for you to derive the polyatomic ions. So what I want you to remember actually is to know the ic acids or the reference ic acids. This one. Alright? Now let's proceed with other monoatomic and polyatomic cations and anions. So for this list, I'm giving you this because they do not actually follow the rules here in the diagram. Alright, so let's have Cn negative, that is cyanide ion. CnO negative is cyanate ion. SCN negative is thiocyanate ion. MnO4 negative is permanganate ion. MnO4 2 negative is manganate ion. C2H3O2 negative is acetate ion. OH negative is hydroxide ion. Cr2O7 2 negative is dichromate ion. CrO4 2 negative is chromate ion. S2O3 2 negative is thiosulfate ion. O2 2 negative is peroxide ion. Remember this one. Peroxide is different from oxide. Oxide is just O2 negative. NH4 positive is ammonium ion, which is different from NH3. NH3 is a neutral compound. It means that it has no net charge, and this is called ammonia. Alright, so ammonium ion is different from ammonia. Alright, so that's it. I hope you understand the system in naming and deriving polyatomic ions, and also, as we discussed earlier, I hope you also understand naming monoatomic cations and monoatomic anions. So that's it for today. Bye-bye. See you again.